need you to do. I need you to set up a new REPL, okay, create a fresh REPL. If you have already started in on the functions for the chapter, maybe somebody has, probably most of you haven't, but if you have already started in, go ahead and start a new REPL anyway. I'll assume that you have a fresh, clean REPL. If you did not know, you can go up and click top left on the name of the particular REPL project and change that name if you want. I would suggest that you call it something like Chapter 2. Here's a situation that you will find yourself on later in the year, and I've done this deliberately, okay? You'll write functions for one chapter, and then the next chapter, the next chapter, and so on. And then you'll be at a particular chapter, like, I don't know, maybe chapter 6, and then you'll think, oh, wow, it would be really useful if I had this chapter, this function that was in a previous chapter. I wonder where that was. And then you go and look around. It's like, oh, yeah, it's chapter 3. And then you can go to the chapter 3 REPL, and you can go pull the function out, and you can use it, okay? One of the really nice features of functions is that they're like these separated chunks of code, right? It's really easy to just go grab it out of one project and drop it into another project, and it'll work the way that it worked before. Okay, that's actually one of the best reasons to always write functions. So make it chapter 2. I mean, that's for you. Ultimately, it doesn't matter to me, but from your point of view, I think that would be a good idea. So here's a fresh new REPL. Okay, and then in another tab, go to my website. So here I am at my website. Open up chapter 2, and then click on functions. Okay, click on functions. And you will see instructions, right? You see the instructions under functions? Are you there? Are you with me? Now, this is something I really need you to do. This is not like one of these sort of optional exercises where it's like, okay, so it's Friday afternoon and it's 10th period and I really don't want to do this. You got to do this. Okay, so this is the way the project will be structured. And you need to get this figured out. You need to get this done now. Okay, really. I won't be particularly pleased if you were in class and then at some point later next week, perhaps, you come up to me and you say, how do you do this again? Well, I guess I'll say go watch the video, but might as well get it done right now. Okay, so you need to do this. Instructions. Are you with me? About thumbs up. Okay, so it says, write each of the functions described below. Okay, so you'll do that. And we'll actually come and do one of them together. They'll all be in a single file. Okay, that REPL project you just created, okay, that's where they will live. Use the function names given. I'm about to guarantee that will be true. Okay, I've done something for you. I'll show you in a moment. It says pay a close attention to the order of parameters. We'll do that too. We'll do at least one example together. So yeah, I mean, look, you're about to see that I've created skeleton functions for you that you'll have to basically fill in. And part of what you'll have to do is you'll have to provide the parameters. And one of the points here is that in each of the function descriptions, I tell you what that order of parameters should be if you'll just pay attention. Okay, I've also provided examples of function calls. You remember when you call a function, you actually feed it values, inputs, right? And then you see the output in the console. I've given you test cases. Okay, if you were to scroll down for, I don't know, the one that we'll do is circle area. So there's some test cases right there. Okay, so once you get the circle area function written, you should be able to call it with those inputs, an input of 1 and then an input of 5. And then you can compare the output of your function to that number there, and at least partially verify that your function is correct. At least it's correct for those input values. And you do understand, of course, that triple greater than symbol, that's the standard Python console prompt. Unfortunately, that's not the prompt that's used by REPL. I dislike that. Oh well, I don't know why they wouldn't follow tradition in this. But when you see anything like this ever in my book, Think Functional, you know that you're in the console. Okay, and that's a line then of code that should be typed into the console, and then you hit enter. Okay, so let me show you what I've done for you. Okay, so third paragraph here. Do you see where it says, I've provided skeleton functions for you? Do you see that? It's underlined, which means that it's a link. Click on the link. And here is where you will find yourself. Okay, here's where you will find yourself with skeleton functions. Now, I wish that you could click raw. You can try it if you want to, but I think I know what will happen. If it worked, you would get just the raw code. Okay, and then what you'd be able to do is go Control A to select it all, and then Control C to get it in your clipboard. That's what we need. But you get blocked, right?
Yes, sir.
I will try to find out if I can get that fixed. I would really like for you to be able to type click raw, but you can't. So just go back. Okay, so you see something like this, 47 lines and all that, right? You see all that? Select all of that, okay, which is easy enough to do. So select it all. And then once it's selected, hit Control C. So now all of that has been put into your clipboard. And then go back to that fresh new REPL project that I suggested you call Chapter 2. Click in the middle section in the code editor. This is code. And hit Control V. A number of people in another class thought I said Control P. It's not Control P. Actually, that does something cool if you want to try it at some point. But Control V should drop this code in. Did that work? Okay, so you're with me. Now, what is this? These are skeletons of all the functions you have to write. Okay, the names of the functions are correct, so you won't have to change that. You'll need a function. You'll need all these functions. Okay, but what it doesn't have is parameters. Notice that the parentheses are in each case empty. So you will have to provide the parameters, the variable names that go in there. Again, we will do one of these together. We'll do circle area. And then also you'll have to write the body of the function. So that pass will have to be replaced. The reason that I put that pass in there is that I didn't want this bit of code to crash if I hit run. Like for instance, here's something you can try. Go into that first function that's called quotient, remove the pass, and then hit run. Crash. I didn't want to crash. Now, why did it crash? It crashed because this function had no body. Okay. There needs to be at least one line of code in the body of any function, and one way to achieve that, and I will hit Control Z to get back to where I was before. You know that, right? Control Z takes you backwards, which is extremely useful sometimes. If you like do something and you didn't mean to do it, it's like, oh, I did it like 5 edits ago. You can get back to it. Control Z goes through multiple depths. Okay, so the pass is the required line of code, but it's a line of code that doesn't do anything. And it quite literally means it's like, hey, I'm code, but I don't do anything. So just pass on to the next line of code. Okay. And it's typical for Python programmers to do this. If they have a place where they know that they will need code, but they don't want to write the code yet, they will put pass in. Okay. So Python doesn't crash, and then it's like a message to yourself that you need to come back here at some time and actually write the code. And mostly what you will do then is write the bodies of all these functions. Yes?
It's kind of like the pound symbol?
A bit. I mean, I think that would work as well. I think you could just slide a comment in there if you wanted to. I think that would work. Or you could just like type 2. That's a perfectly acceptable line of code. You see no crash. Kind of strange though. What does Python do when it sees 2? Basically it goes, yep, that's a number. I know that. Ooh, wow, that's strange. They didn't want me to do anything with it, but okay. And then it moves on. Okay, it's perfectly happy with that. Like you can type 2 into the console, and what does Python do when you type 2 into the console? Well, we can find out. It says, yep, 2 is 2. In other words, what do we evaluate? What do we get when we evaluate 2? 2. There's actually a name for an expression like that, such that when you evaluate it, you get the expression back again. It's called a literal, but you really don't need to know that, but that is the name for that. Okay, so you've got all the function skeletons, okay, and you will fill these out so they become completed functions. Now, let me show you the second part of what you need to do here. So go back to my website, and in the instructions section, look at the final paragraph where it says, below all your functions, paste in the unit test. So that too is a link. So click on the unit test link. And then once again, it would be nice if we could go to raw, but we cannot. Instead, what you'll have to do is you'll have to select all of this code. And this is all code that I have constructed. I think it was about 2.5 years ago that I realized that I now had sufficient knowledge of Python to do what I have done, and you'll see what all this does in just a moment. And once I realized that I could do it, I also realized that I had to do it. Okay, so Select Control C, go back to, wrong spot. Go back to your project, your REPL project for chapter 2. Go underneath, okay? Go underneath the code that you had before, of course, back all the way to the left, and then Control V that in, okay? So you now have all the function skeletons together with the unit test. Now, what does that unit test do? Well, perhaps the best way to begin to understand what the unit test does is this. Click Run. Yes, something, but not in the console. Do you see where something happened? Do you see what is different?
Here's 280.
Look on the left-hand side. Do you see that a file has appeared? Do you see a file called report.txt? Click on that. Oh my God, here it is. So apparently the unit test code generated this text file called the way of the function unit test. And look at what it did. Okay, here's what it will try to do. It will send input values, typically called arguments, okay, to your functions. It will compare your function's output to the value that I know is correct, okay? And then if your output agrees with the value that I know is correct, if they are the same, you will get a point. And if they do not, or if your function crashes, you will not get a point. Okay, so now all of these functions are just skeletons at this point. None of them have been completed. So of course, we don't get any points at all. So scroll down to the bottom, and you get a summary. And the summary tells you for each of the functions how many points was lost, and then you get a score. Okay, so everybody's score, I suspect at this moment in time, unless you like pasted in some function you wrote previously, or maybe you just did one, but I suspect that everybody's score at this moment in time is 0 out of 43. And if you were to just like totally leave this alone and not do a lick of work in the next week and a half, oh, and the due date is Wednesday of the week after next. Okay, so you got plenty of time to work on this function set. If you don't do a lick of work, I'll put a 0 out of 43 in the grade book. Okay, but you will do some work. Okay, you will get some of these functions written. And here's what's really cool about this: whenever you do a little bit more, or whenever you want, you can hit the run button again. And the unit test will generate a new report, and it will just overwrite the old one. Okay, and as a matter of fact, I'm about to write one of these functions with you, and I will get you 3 points.
I was going to ask, do we write this underneath the previous code, or do we write it into the
You put, so at the end of the first code we put in, you press enter, backspace, then you paste the code we just
Yes.
got into the.
So it should look like this, right? It should look like
Yes.
function skeletons and then unit test.
Do we write into the skeleton function?
Yes.
Okay.
Okay, the unit test you leave alone. Okay, I mean the unit test will reside. The site that I sent you to get the unit test is GitHub. Maybe we'll talk at some length about what GitHub does. It's really an important tool. I only use it for code distribution. Yeah, I mean if you like do something to the unit test, I mean you'll probably break it if you do anything good. But if you can't like get back to the original version, you can always go and grab it again.
I didn't know if we start after the line and start typing.
What you do is you fill in
Oh,
the
we
skeletons.
fill in.
Okay, we're about to do one together, right? I want to make sure that
That's why I
everybody's
put my hand down.
super clear. Yeah. Okay, so how about this? Go back to Think Functional. Okay, so again, this is the functions page for chapter 2, and every chapter from here on out will have the description of the functions that you're supposed to write. Okay, so let's go down to, we'll do a really simple one. We'll go down to circle area. Oh, and then look at that. Fahrenheit to Celsius. You'll write a function that does that. So write me a function named circle area. You know what? I've already done that. That's one of the skeletons. That takes the length of a circle's radius. Let me stop right there. What a function takes, that's the value of the parameter. Okay, that tells you what the parameter should be. That's what the function needs at the start to do its work. That's radius. Okay, so it seems to me the right choice for the name of the parameter, which we will go type in just a moment, is radius. And then what we're supposed to return is the area of the circle. And then make use of that value for pi, 3.14159. Do that, okay? So here's what's going to happen. Here's how the unit test works again. It will compare your output to the output that I say is correct. And if they differ, you will not get a point. So if you decide that pi should be 3.14, you will get slightly different values for your areas. And then my unit test will go, well, that's a different value. And you won't get any points, okay? So take me seriously here. The value for pi that you need to use is 3.14159. Yeah,
The test, is it evaluating the code we're writing or the output we're,
only the output.
okay.
Okay, the unit test does not look at the code. That would be like crazy high-level AI stuff that I don't even think exists yet. Because that would be basically, okay, so you AI, look at this code and tell me whether, if it is run, it will produce the right input, right outputs in all possible cases. And given that most problems can be solved in literally an infinite number of distinct ways, the level of intelligence that would be required to have some sort of system look at code and know that it is correct in all possible cases is far beyond any piece of software that any human being has yet produced. So, no, it doesn't do that. Instead, what it does is it just checks the output. Okay? Yeah.
Couldn't it take the equation that it's looking at, turn it into, shove it into a new, not for a program, or what's the thing on the left folder? Oh, well, like report.txt, but a new one, and then see if it runs. And if it does get the correct output, then it'll say, yes, it works. Or if not, no, it does not work. Could it not do that?
Well, I mean, in effect, that's what the unit test does. Right? What, are you trying to describe some clever way to cheat?
No. I don't even know how to do that.
I didn't really follow there. So let me go ahead and show you. So we can chat later on. Sorry, I'm kind of tired. I didn't really follow. Tell me in a few moments. Okay, so you're going to get the value for pi, right? And then we're going to write in the circle area formula. Okay, so let's go back to, oh, there it is, circle radius, right? It needs a parameter, and that'll hold the input value. Okay, so it's radius. I mean, what does the area formula for a circle need to compute the area? It needs the radius. And then I told you that pi should be defined as 3.14159. There we go. And then let me show you something quickly. You might not have done this. You can actually have Python do calculation, do work on the return line. Now, I wouldn't suggest that you have it do lots of complex work, but you can have it do a little bit of work. Let me show you what I mean. Okay, the area, of course, is pi r squared, so written as Python, that's pi times radius double star 2, pi times radius squared. And my point is that this is perfectly acceptable for Python, okay? And it should come as no surprise that this is acceptable for Python, because here's what Python will do when it hits line number 9. It will go, okay, return. Ooh, the function is almost over. That means that I have to go to the bit of code after the return and evaluate that, okay? Python goes, oh, there's a little bit of complexity here. That's pi times radius squared. Okay, so I have to evaluate that. Oh, so I replace pi with 3.14159 as a variable. And then, oh, the radius will be, of course, whatever we send to the function when we call it. And then it will do the calculation. And then when it's done with the calculation, that will be the value that's returned. Okay, so yeah, absolutely. You can have an expression that, work has to be done to get the value. Python doesn't care; it'll go and do the work. Okay. Now you could, of course, also have an additional line of code that says something like area equals pi times radius squared, and then you could go return area. That also would be acceptable. But this expression after the return is not too complex, so I think that's fine as well. Okay, so I have now written the circle area function. Hit run again. Now go look at the report. Oh, if you go back up to the circle area output report, I now got 3 points. Okay, for all the input values, I got the correct output value. And if you go down to the very bottom, you will find that you now have a score of 3 out of 43. That's how this class works. Okay, so in every chapter, you will have certain functions that you're supposed to write. I mean, and of course, we learn lots of new Python as we go through, but ultimately all that code will be within the scope of some function. So you write functions, and then you've got a unit test, and then you run it the unit test, and the unit test generates a report. And the hope then, of course, is that over those days, those weeks that I give you for a particular problem set of functions, that number of points will increase until hopefully, I guess, for most of you, it'll get to 43 out of 43. So that's the goal. Okay, that's how this class works. There is one feature of the unit test that I don't much like. Okay, that I don't much like, and I'll have to rewrite the unit test at some point. The unit test has undergone various revisions, small and large, since it was first created about 2.5 years ago. And one of the major revisions that it needs to undergo that it hasn't yet has to do with errors, has to do with crashes. Okay, now go back up to the top. Okay, so look, for instance, at the quotient function. It says crash. Okay. And you might think, well, okay, so if there was a crash, how is this program able to execute all the way to the end, and why don't I see like a red error message in the console? Well, the answer is this. Python and all modern languages allow you to catch crashes, okay, and then handle them, deal with them in some way, instead of, like stop the program and get the red error message. Okay, you can do that, and we'll talk about how to do that in a later chapter. The unit test does that, okay, and for good reason. That is, I want to be able to generate a report even if your function does something silly like, I don't know, misspells a variable or something like that. I don't want the unit test to crash. I want it to continue on through the end and generate the score. Okay, so I catch those crashes. But the bad aspect is that if one of your functions crashes, like they almost all do at this point, because we try to send them values and they don't have any parameters at all, so of course they crash, is that the bad feature is that you don't see the message. You don't see the error message, okay? And those error messages can be extraordinarily helpful. And I don't much like that, okay? That is, I would like the report to actually print out at least a portion of that error message, okay? And I'm not exactly sure how to do that. And also at this moment in time, I don't have the bravery to go and restructure the unit test, so we'll do that because here's what will inevitably happen. I will break it. And it will stay broken probably for weeks. And I will be in a state of frustration until I actually figure out how to make it all work. And I know that I eventually could, but I just, I'm not quite brave enough to undergo that process. Now, there's a kind of workaround, okay? And here's something I found to be the case. In this class, I've taught it 7 years now, and there have been various problems, with computers and the environments in which we program and everything. But there's always been some workaround. And by workaround, I mean a way to get where you're supposed to, a way to get where you want to be, but probably not in the most efficient way and not in the way that you thought you could do it initially, okay? It's sort of uncanny how it is that there always turns out to be some kind of workaround. It's weird. But the workaround in this case is this. Okay, so let me go into the circle radius function and let me break it, okay? So I actually did this in my first class today. Okay, so I had radius as the parameter, right? So I should have spelled out radius on line number 9, but I didn't. I just wrote it as R. I didn't pay attention, okay? And now if I run and go and look at the report, do you see what it says about circle area now? It crashes, okay? It crashes because that R is not defined. Well, if you wanted to see the error message, here's what you could do. Okay, so I hit the run button, right? And that means that Python, which, as you know, lives in the console, knows the circle area function. So I can type in circle area and I can send it a value, okay? And this is the sort of thing that you would want to do, right? So if you have written a function and you run the unit test, and the unit test says that your function crashes, but you don't see the error message, and you'd like to see the error message, and you probably should want to see the error message. It often really helps. Call the function in the console, okay? And then there's the error message, right? It says name R is not defined. Oh, and that's really extremely helpful, right? Because if you go back to the function, you would see, oh yeah, look, okay, so the parameter was named radius, and I need to spell it like that whenever I use it inside the body of the function. So I spell radius, and then now if I run, everything will be fine. Okay, so if it says crash in the report, and you want to see what the error message is, just go call the function yourself inside the console, and it will show you that error message. Okay, that's it. Are you set up? Is everybody up to 3 out of 43 points now? If it says 3 out of 43, you're on your way, okay? And you know how the rest of the course will be structured. It'll be structured like this, okay? And then, of course, your task from here on out until the end of the chapter, which this is due Wednesday of the week after next, so you got quite a time to work. Your job is to get all these functions written, right? And hopefully get up to 43 out of 43 points. Okay, any thoughts, any questions?
For
Yeah.
the unit test, it doesn't show the code.